Hey guys, welcome back. Um, a couple of you requested about some of my WPL 18650 hacks, which are not really hacks, but whatever. So I was going to talk about what cells you should use depending on the size of your vehicle and batteries in general. So there's a couple ways I make my homemade 18650 batteries, like this one and this one. I use my $100 battery spot welder and nickel strip and spot weld it in, which works pretty well. But the issue is with some ESCs, you got to look at the minimum voltage cutoff for the batteries because LiPos don't go down in voltage as much as lithium ions, and LiPos will be at a higher charge nominally when they're fully charged than lithium ions will be. So some lithium ion cells only go up to 3.8 volts, but they can go down to 2.8 volts, so they can drop an entire volt, or even lower. Some can even go to 2 volts per cell. But then that makes the entire pack only, 4 volts, which the ESC will cut it off at like 7. So you can't get, like, you get 5 minutes of runtime, and the damn thing turns off. So you gotta look at ESC and cell type. But some cells will go up to 4.2 volts and only drop down to 3.6, so it works better. So LiPos, it says, like this one says 7.4. This one's pretty much fully charged. This in here. And it says 7.5, and that's half charged then. So then if it drops down to 7, then it'll cut it off for saving it. But that's a 2S. A 3S, this one is fully charged. I just charged this one. 12.5. You won't get up to 12.5 with some of these cells compared to some of the 1860 versus the LiPo because the chemistry is different. So what I do is try to find ESCs that go down to a lower voltage, or sometimes if it's got a nickel metal hydride setting, you can use that, and sometimes it tricks it thinking it's a different, because it doesn't have a cutoff, then you gotta watch it better, but sometimes it works better, so you just gotta watch it sometimes. But so on the WPL I used these 18650s, and if I don't have to battery spot weld them like this or this, because these are higher amp continuous out, you know, yeah, continuous amps out versus these gray ones. I have a lot of these gray cells. They're from medical stuff. I got them from Battery Hookup, which I bet you've heard of by now. I have about half of them than I did. I had 180 of them, something like that. But see, these are only rated for NCR 18650 MH 12210. These are rated at 2900 milliamps, which most of them were about 95% capacity or higher when I got them. Some of them were dead though. But they're only rated for 5 volts maximum out current, so that's why I put some of them parallel. This one is supposed to go on a flashlight for my grandpa. But like these ones are different. These ones are, I believe, oh yeah, these ones are for our drill batteries, and these ones were not drill batteries. I just bought them new, and they're rated for 10 amps out. So that's why I put two in parallel. So these ones kind of work. These ones are mainly for my smaller, like 1/12 scale machines, because they're still those ESCs, the smaller ESCs, they can go down and they accept the lower voltage, I guess. So that's nicer. But like my WPLs, I like making battery packs that they come. I can take the cells out and charge them individually instead of trying to get balance leads, because I have like this one. I got my smart charger here, and then I can balance all the cells. So on here you can see nickel metal hydride is 1.2 volts, lithium ion 1.7, Li-Fi at 3.2, and Li-ion different lithium ions at 3.85. I think that these 1.8 3.85 cells would be a lot better for RC car batteries than the 3.6s, because it's higher voltage for the whole pack then. So if these were fully charged at, let's say you charge it a little overcharge them, so almost 4 volts, so 3.9, then the entire pack would almost be 8, yeah, almost 8.5 volts depending on fluctuation. But these also drop down during, these gray ones specifically, drop down in voltage way more when the more loads on them, like a normal battery. But since you're only using two, you have to rely on a single cell like this. That's why I only use these in the small WPL stuff, because they only use, in a pack like this, because they only use like an amp to 3 amps max. when you're really going through it. But the 380 motor, no, I'm sorry, 370 motors that are in them use maybe 4 amps max when you're really bogged down, but then, you know, the ESC will get hot anyway, and you'd probably notice it's really bogging down. And these JSD connectors can only take 6 amps max, so these gray ones are okay for output. But I would just use these LiPos if you're getting WPL. They're for WL Toys small RC cars. They're only like 16 bucks. You get a 2-pack. They're 1100 milliamps. So you can run a really long time for a WPL. But sometimes if I'm on the go and I don't have a voltmeter with me, I'll bring this, because this is for a Raspberry Pi power supply, and it uses 18650s, and it gives me a nice, so this was mostly charged, so one of the cells is a little lower, but I can't charge anything with it, but it's nice to know what voltage they're at. I should probably get a portable. Well, now, since I got this thing though, this thing has, I gotta take it out. Shoot it out, alright. You can use a USB out for stuff. So I could charge, let's say, the camera on the go, and you could put USB out, and it'll tell you the, you know, percentage-wise for batteries, nickel metal hydride or lithium ions, which is nice. But like these green cells I got here, I got a bunch of these too. These are Doe batteries. They're rated for 20 amps out, each individual cell, but only a maximum voltage of 3.65, maybe 3.8 if you get lucky. But that's the thing, they don't have a high, they have having like a half of a charge. The ESC thinks it's only half of a charge battery, but in reality it's just how those cells work. So you really just gotta look at the cells. But sometimes, like these batteries, these are great because the charge controller might work like a boost converter, I can't remember now. It'll bring the voltage up higher when there's more draw, but it's got its own safety current limit and voltage cutoff, so it's good for ESCs. But as you can see, it might not fit in all holders. So this is a bare cell. It's a Panasonic. Oh, it's kind of hard to tell in the camera. Hold on. Let me get a better cell. So they're both equal height, almost. This one's a little bit taller. It's like 2-3 millimeters taller. So it might not fit in some of these cell holders for batteries, because it's just like 2 or 3 millimeters somehow can make such a big difference in these battery packs. So it might fit in this, but you need to give a little persuasion. Yeah, you might have to give a little persuasion, because it's usually on this one I can move it. But this one, that's all the way in there. So yeah, it's like that. But like, see, so voltage on these blue cells could be a little higher than the gray cells. And like I said, you got to look at the chemistry and stuff. It's all about figure out which batteries you need. Yeah, see, these blue ones, 4 volts. You put them together, it's 8 volts. You can run some ESCs off that. So let's say, yeah, these are red Panasonic cells I got out of a laptop. These are also 4 volts. Okay, so some of these lower discharge current ones, probably like this gray one too, they're probably at 4 volts. Yeah, 4 volts. Okay. And also the draw could be higher than you're expecting. That's not good. Yeah, that one's at 2 volts. That needs to be charged anyway. Some of these cells might be going. That could be my issue with some of these ESCs not liking the drill batteries. They could be dead. Anyway. Oh, I know these green ones are kind of picky. Those are also at 4 volts. So yeah, make sure you have good cells too. Because now I feel like I have an issue with myself. Yeah, I need to recharge all my clean cells here. Anyway. Oh, yeah, I know the other bed. There, see, 4 volts there. 4 volts there, so these are good. I probably should just use those instead. These green ones have always been kind of finicky, but like, yeah, so it just depends on chemistry. Let's see, I don't even remember what are in these ones I sealed up. Okay, those need to be charged. I don't use some of these sometimes for a while. 8 volts. See, this one would probably be okay, so I gotta try that one. But, like, I haven't put on the channel yet, but I got a new RC car, and I'm trying to use a set of 18650s instead of trying to, use LiPos, because it's such a small car. It's 1/14th scale, so it says 1/12, but it's really 1/14. Let's see if I can charge these. So yeah, you know what I bet would happen? It thought, yeah, I bet this thinks it's a nickel metal hydride cell instead of a lithium ion because the voltage is lower. So, like some of these supposed smart chargers, you gotta make sure. Oh, that one is good. Okay, this one's good. You gotta make sure that the cell itself is good. So yeah, 2 volts. This needs to be charged. Oh, that's not 2 volts. Yeah. So you just gotta make sure your cells are good too. Like, I guess I'm dumb and forget. Also, these have been sitting for like a few months. So, but yeah. Also make sure the self-discharge rate isn't too high. That kind of stuff. So. If you want to see more videos, I'm going to 3D print some stuff for the WPL. I've been doing some work. Oh, I guess I'm going to drop stuff. So I got this done. I got fans in there. I'm going to make it 18650 on the back, 4P2S, or maybe 2P2S, we'll see. But I redesigned the suspension so I got a lot more travel. So, we'll see on that. But thanks for watching, guys, and I'll see you guys next time.